Hi everyone, my name is JD Tamucci and today we're going to be going over how to make standard curves in Excel 2016. So before we start doing this, let's just talk about what a standard curve is real quick. So a standard curve is something you use to predict something you don't know. So in this experiment, we had an unknown sample that had a concentration that was unknown, a concentration of BSA that we didn't know. So what we did was we made standards with a BSA concentration that we did know over here. We made these standards that had a concentration of 0, 0.25, 0.5, 0.75, or 1. And then we measured the absorbance of these samples right here. So then what that allowed us to do was then we can go in reverse. We find the absorbance of our unknown sample, and then we can work backwards using a standard curve we produce to find the final concentration of BSA in our unknown. So let's solve this mystery together. First thing we need to do is input our data into Excel to make a chart and eventually find a equation for a standard curve that we can input our absorbance into. So we'll be copying this over. So we're going to put BSA concentration, milligrams per milliliter, and we'll just be copying this data in 0, 0.25, 0.5, 0.75, and 1. And then absorbance at 550 nanometers, which was the lambda max. And it was 0.4, 0.8, 1.2, 1.6, and 2. Okay, so now we're going to select this data. I'm going to come up to Insert, go over to the graph with dots, click on that, and then click on Scatter. I'm going to make this a little bit bigger so it's easier to see. First thing we'll do is delete the title, because we don't use titles like that. We put our titles below the graph as part of the figure legend. So now we're going to add axes titles. So for primary horizontal, the axis title would be BSA concentration milligrams per milliliter in units. Always have to include the units. And then we're going to come back up here, add the vertical axis title, and put absorbance at 550 nanometers. It's very important that we put what we did it at so they know that we tested this at the lambda max. Next thing we're going to do is select the data. So if you just click on one of the points, you'll see that they all get selected. If they don't, then click somewhere else and come back, try it again. And then we're going to go back up to Add Chart Element, scroll down to Trend Line, and click on Linear, because this is a line. So this is good. This is a standard curve, but we want to be very precise with our prediction. We don't want to just estimate like, oh, it's about 0.47 or something, just a guess. We want to know exactly what it is. So we're going to get an equation for this. So if you double click on that trend line, then this menu will pop up. And if you scroll down to the bottom, you're going to see Display Equation on Chart. Check that box, and then you can X out. And here's that equation. We'll drag it so it's not on a line. And voila, we've made a standard curve. This is what we would use to solve for our BSA concentration. But now, let's put it into the context of a lab report. So I'm going to right-click, copy this graph, paste it into by right-clicking and pasting, with our other graph at the last page of our lab report. And we're going to add a figure legend. So this is something these are the kind of things that I would include in a figure legend. But of course, don't copy what I do exactly, because that would be plagiarism. But just take note of the kind of things that we're including. So this is a standard curve for BSA concentration. The title tells the reader what we're looking at. And then this is where this would be after the title, the short description, but afterwards that explains what we did. So we measured the absorbance at 550 nanometers, which is the lambda max. So we're going to come back up to insert equation. We'll put backslash, oh, that's not what I meant. There we go, backslash LAMBDA. Make this graph a little bit smaller. Okay, well, do this one more time. Backslash LAMBDA, hit space. That'll give you a lambda symbol, and we can put max. I'll highlight max, come up to the subscript button to make it a subscript. And then we'll say for the Biuret reagent in presence of BSA, which is a polypeptide. And they can see figure 1 for the data that shows where we found the lambda max. And we'll say that we did this for 4 BSA standards, test tubes 2 through 5, and a negative control, which is test tube 1 was a negative control because no BSA was added. Typo. Okay, and then we'll say that this standard curve, oh, another typo, was used to determine BSA concentration, milligrams per milliliter, in our unknown sample. And we'll point the reader to the results section to find the absorbance of the unknown. Notice though, here I don't put the predicted concentration of our unknown that we find. That's not part of this section. Technically, graphs are part of your results, so it wouldn't be right for us to include a prediction in our results section. That's something that you do in the conclusion. So just to sum things up, that is how you make a standard curve. If you have questions about how to do this, feel free to reach out to your TA. And otherwise, have a good day.